Okay, so here we're illustrating the linear elastic region. We can go up to healthy strain level. When we release the beam, it returns to 0. So here is 0. Large load, and it returns back to where it was. What we have here is a Micromeasurements EP series strain gauge. This is a 500 BH pattern, 120 ohms, and it's installed with Micromeasurements M-Bond 812. So this gauge can go, with that adhesive, can go to 20,000 microstrain. And we're first going to illustrate that we are close to 0, and we're going to illustrate the elastic region of strain measurement. So I'm going to flex the beam within the elastic limits of this aluminum and then release it, and you can see how it returns back to 0. So this is illustrating that the aluminum is behaving like a spring and the strain gauge is tracking. Now we're going to strain it to the ASTM defined yield point. Now with the same gauge, we're going to attempt to get a 2000 microstrain offset, which will be the ASTM defined yield point. This may be difficult to do, may take a few tries. Okay, close. And I just passed it, just slightly. So we are just past, but very close to the ASTM defined yield point. You can see that the beam is now slightly bent. And the gauge is still functioning.
Here we have a CEA strain gauge bonded with M-Bond 200, and we're going to go to the, watch it as it goes to in the elastic range. Has good 0 return. Well in the elastic range. Going to go back to 0 every time. And now we're going to go to the plastic range. We're going to yield this beam. We are beginning to see some yielding. I'm going to go up again. I'm going to go to higher than 6,000. Go to 10,000. And let off. Now, that's the 2,000 microstrain that is officially yield. 0 return is down to 0.2%. Now we're going to go to catastrophic failure. And the gauge delaminated. Take a look, see? It's flapping in the breeze.